Well, hi, good morning and welcome to my shop. Thank you so much for joining me here. Today is June 17th, the last, last of the cool days. At least it's starting out cool. And in just a couple hours it's going to be 30, 31 here with high humidity. It's going to stay that way for a few days. So I'm joining others in the world who are experiencing heat. Of course, this heat is not extreme. You can't call 30 extreme. No, it's just hot. So, what about this radio? So I think it's time to do the alignment, or run through the alignment process, and see if we can get any performance improvements out of this radio that way. Let's take a look at the instructions to start off with. So here's the schematic. The instructions are here. I'm just going to zoom in a little bit. I've read through these carefully, so I kind of know what's here, but this is what we're doing. Step 1. Set variable condenser to minimum and turn waveband switch to broadcast. Okay, I'm going to do that right now because I'll forget if I don't. And set the capacitor to minimum, which is to say closed. Okay. Introduce a 456 kilocycle signal on the grid of the 6A8 tube. Adjust bolt trimmers for each of the two IF transformers. Maximum deflection on an output meter. So the output meter, they recommend you connect it to the voice coil. I'm not going to do that. Instead, I'm going to be following the AVC voltage. I'll show you where I'm picking that off. Typically you can get the AVC voltage at the volume control, because the volume control is the first thing after the detector. So right in this area, so you can see they are piping the DC this away. This is probably a very large resistor here. And then the DC is being used to affect the grids on this tube and this tube, and maybe that's it. Just on those two tubes. The signal I'm going to be using, the 456, I'm going to pump into this grid on this tube, and I'm doing it by attaching my signal generator to the tuning capacitor at this point on the tuning capacitor. It's very convenient for clipping too. So signal in here, monitoring the output here, and tuning up these two transformers. That's what we're up to. 456. Okay, that's good. Okay, 456. Let's get this set to 456. Even though it says 55, you got to kind of add a number on here to get the real value. So 455, 456. It can't be that much of a difference, I would think. So we did turn on the radio and get it going. Now I do not actually have this connected yet. The clip lead is hanging open behind the radio. You can't see it. Oh yes, here it is here. Not connected just yet. So let's get the radio operating. So volume down. Here we go. There's no antenna connected. Actually, I think yesterday's video ended with me testing the radio out, and I had it connected to the antenna lead, but I didn't have the switch thrown at the other side of my house, so it actually was nothing very good attached to this radio for an antenna. But it seemed to work pretty good. What do we got here? What is that? Okay, we're in business here. We are running the radio with 80 volts. That's a little too low for this kind of stuff. I'm going to give it the full. Some of those pops, they sound like the radio. That stuff. There's some motorboating in there. this clip lead may be shorting out in here. I'm going to turn the power off. Not that there's any power here, but let's try clipping it here. So this is going to the voltmeter. Let's try it there. Does that make any difference? It may or may not have been shorting. There's still lots of, like, there's molded capacitors in here. They aren't particularly good either, and they could be responsible for malarkey. Okay. Ooh, what was that? Okay, malarkey seems to be gone. Yeah. So, now the occasional pop there, pop, pop, that stuff. I don't think it's the radio. I'm not sure though. Okay, well we should be hearing something here. No, I don't have the modulation on here. Let's put the modulation on. Okay, oh, I don't have the connection made yet. We're just checking to make sure the radio's operating. Those pops, I don't know, boy. I would say that's something giving up the ghost in this radio. Very quickly giving up the ghost. I don't expect this to do anything, by the way. Let's run it on a little bit of a lower voltage, see what happens. So we're down around 93 volts. Didn't seem to help much. Well, I'm pretty sure that's the radio itself. I don't think that's external interference. There's no pops. This could easily be a tube doing this kind of stuff. Well, let's carry on with what I intend on doing. So first we want to hook up the signal generator. So I'm going to put it on this connection here. There we are. Checking the meter operation. Very good. Meter peaks there. I don't need to listen to this so loud. You can see the frequency the radio's tuned to, the peaks at Probably 455. Okay. Now it could be a sloppy 455. Let me get a tool here. Let's try this. Okay, I think I can spin this all the way around. You want to keep an eye on this. Whoops, an eye on what? An eye on this. And I'm just going to turn my signal generator up just a wee bit. Can't even notice I changed it. Now we're going to try to max out this meter here. I'm going to get myself right in front of the camera. Okay, second IF first. This is not good. I can't see what I'm doing. I got so much wire to the speaker here. And the clicking really settled down when I started feeding in a signal. Okay, I'm in the first one. Here we go. Down. Right on the money. Okay, other trimmer. There we go. Oops, cammed out. Here we go again. Oh boy. Why so hard to turn? Holy smokes, maybe my screwdriver's caught? Need a bigger, badder screwdriver. Okay, I'm in. Here we go. Oh, this screw is really tough. And it's right on the money also. Okay. Well, usually radios are a little out. This one's not. Okay, we'll go to the other transformer. Try to get my screwdriver in it. Lots of static is back. Okay. No, that can't be in. Okay, now I got it. There we go. No, my screwdriver's falling out again. It's easy to get the screwdriver jammed between the screw head and the opening in the IF can or other things. Get it jammed, but it feels like it's in the screw, and give it a good turn and bad things happen. Here we go. Right on the money again. And this screw was also stuck, so it's as if it has not been, nobody's done anything to this for ages. Here we go. No. Last one. Okay. This way. There we go. Right on the money. This was like the best tuned radio I've ever I've ever checked. Just dead on. Okay. Well, I guess we'll just go on to the next part of the alignment. The next part of the alignment here. Remove the signal from the grid, feed it through the antenna. Adjust the 456 interference trap trimmer for minimum response. I'm really interested in this adjustment. Not a lot of radios have these, maybe 1 in 10 or something like that. More expensive communications receivers have these kinds of traps. And I let a radio slip by a couple radios ago, and I didn't realize that it had a trap like this. I had no information about the radio. So I'm quite interested in the effect of this. So maybe we're going to skip this for now and carry on with these other steps. Then we'll come back to this at the very end. I don't see the reason not to. They've got it here because it's kind of part of the IF deal. I'm going to leave this. Okay, with the pointer at 600, feed 600 kilocycles through the antenna, adjust the broadcast series pattern, headless set screw closest to front. Okay, I'll be able to figure that out for maximum response. Move the point. Okay, so we'll do this. Move the pointer to 600. Move the pointer 600. Why don't we put the signal generator at 600? No. Stay back here. 600. Why? Oh, that may be where the radio's tuned. Let me tune the radio. Yeah, that's where the radio's tuned. Okay, so we'll set it to 600. Here we are. Move the signal generator to the antenna. Which one was the antenna again? Don't remember. Make sure the band switch is where it should be. Yep. That's the antenna. So now we'll tune the radio to 600 here. Oh, I can't even read the dial. That's a very, very small dial. Yeah, I'm complaining. Here. So we're a little off because it's picking it up there. It's picking it up there. It should be hearing it here. 600. Okay. Now, which one was the oscillator? I'm just going to look at the instructions here myself. It says adjust the broadcast series pattern, headless set screw closest to front for maximum response. Headless set screw, the broadcast series pattern, headless set screw closest to front. Okay. Headless set screw closest to front. Oh. Okay, there's a whole bunch of I should really have that speaker right up on top of here. Let's do that. Okay. That's a little better. Headless set screw, eh? So they are those holes in there. Headless set screw. What? That's not a headless set screw. There's no headless set screw there. That's got a regular screw in there. That's got like that's like three capacitors in those holes. Where's the headless set screw? Headless set screw. Oh, there's a bunch more on the other side. Oh my gosh. There's 6 of these, so there must be a 2 for every band. So one's going to be oscillator, the other's going to be the antenna adjustment. And the instructions said this. Adjust the broadcast series pattern. Headless set screw. Closest to front. What are you talking about? Headless set screw. I don't see any headless set screw here. Come back here. Just a second here. I'm looking for my break. Wow, would you call those headless set screws? If you can even see them. They're just ordinary capacitor screws. They're not headless. Okay, calm down. There must be a headless set screw somewhere. Somewhere in this radio. Oh. Uh-oh, there's a whole bunch more adjustments, it looks like. Yeah. So there's 5 things here in view. 5 adjustments. So we've got 3 capacitors here. And then there's this guy and this one. So there's only 2 headless set screws. One is closest to the front. Is there anything like that going on over here? No, set screws are, they don't really look like set screws to me. They look like the tops of slug adjustments. Okay, so those are probably slugs and coils, and they are generally used at the low end of the band, which is where we've been asked to do the tuning. So, okay, the one towards the front then is supposed to be the oscillator. Okay, really? Let's go at it there. I will attempt this. These are probably stuck fast. I can get a better tool. That's the tool I'm going to try to use. Headless set screw at the front. Nope, this isn't going to work. The tube here isn't big enough. So try well, let's just try this. These kind of adjustments, the non-capacitor ones, the slugs and coils, are very sensitive to bringing up a big chunk of metal, like a screwdriver, like a stiff screwdriver. Get in there. I don't think this is going to work. I think you have to bring up a big screwdriver. Oh, jeepers creepers. Okay, there. Oh. Okay, I'm there. Now what am I doing? Just cammed right out. Okay, we're gonna give up on that. We're gonna use a big honking screwdriver. Now, I'm gonna tune in the signal generator. Put the screwdriver up against the adjustment. See if it drifts. No, it does not. Okay, so we'll put the screwdriver right in the slot here. There we are. Now we're in business. Got this big metal screwdriver right beside the tuning capacitor here. Okay, we set this back to the spot, 600, and tune away. Come on, turn. There we go. Okay, I'm watching the voltmeter. There we are. Good. Got away with that. Now let me just check and see, is this really right on 600? Not. Sorry about that. You know, the sounds are very loud on my video. Sounds like sharp sounds like that. Okay, let's put the brake back on. In case you haven't figured it out, I'm down on my hands and knees here. Okay. Okay, we're in, watching the meter. There we are. That's step one. Okay, step two. What is step two? Step three, actually. Actually, step four. So, no, part of step three. I did this. Now we want to go to 1600. Feed in 1600. Align the broadcast oscillator on left row nearest front. Okay, that's clear. And then the antenna on right row furthest from front. And it says align the broadcast oscillator. So we're not actually saying, you know, adjusting a capacitor, right? I'm sure I understand what he's saying. Return to 600, readjust pattern, rocking the variable condenser for maximum response. Well, that's getting a little complicated. Okay, so I want to do the rocking thing at 600. So we'll go to 1600 and we'll do the adjustment there. Okay. Here. Okay, everything to 1600. 1600. Okay, and this guy to 1600. I got 1500 and 1700 marked, but not 16. Right in the middle. Okay, we're at 1600. Don't hear it. Let's hunt around and see where it actually is. 1620. Not far off. Not far off at all. Go there. And I have to read the instructions now to get exactly which adjustment to do. I'll just look at them myself. Move the pointer 1600. Broadcast oscillator on left row nearest front. Left row nearest front. So, you know, I assume we're looking this way. So left is over here. Nearest the front, eh? You really? Is this really what you want me to do? Oh boy. I'll bet you that sound we're hearing is a tube. Left one near the front. Okay, here we go. Hardly moved it. Should be going back and forth. Not going to do that. Move the pointer 1600. Return to 600. Readjust. I'm not going to do that. Return to 1600 where I am now, and check. Wait, there was something more in here, wasn't there? There was a rocking thing. Where'd the rocking thing go? Oh, here I return to 600. Readjust the pattern, rocking the variable condenser. Okay, we have to go back and do this rocking thing. So the rocking thing in my mind is about trying to align three things when you're only adjusting two of them. So you're trying to adjust two of them around the third, and that's what this rocking thing is about. The third one you have to pretend is here. There's the third one. And you're rocking the other two. Okay, that's what I think is going on. Oh boy, listen to this thing. I got my friendly ticker going in the background, and then this breakdown sound. Let's just tap a few tubes here. I can't imagine this will do anything, but could also be just bad pin contact in the tubes. I don't know. Okay, we're not going to get anywhere there. So back to 600 and the rocking thing, right? 600. Okay, 600. Wow, was it that far out? A wee bit out. Okay, 600 will correct the oscillator, which was, let's get it right. Do the right thing here. I think I'm doing the right thing. Okay, now it says rock. Hey, well, that other interference stopped. Okay, rocking. So we'll go a little this way in that. Much difference at all. Sorry, you're not looking at the right thing here. about as high as I can get it. I got it to go from, didn't have to listen to that. I got it to go from 7 up to 9. We're picking up 600. Now where's the dial? The dial may no longer be at 600. So the dial is off 600 now. But I think the name of the game in this kind of adjustment is peak performance, not dial accuracy. I could potentially drive it back using the other adjustment a little bit, but I'll go back and check the other side. Let's just listen to this. Well, we can't listen, there's no antenna. Back up to 1600. Just, things got pretty quiet there, didn't they? 1600. Listen, whatever it is breaking down seems to be getting worse and worse. It's pretty good. I think that's pretty good. What else does it say here in the instructions? It says return and check again, which I just did. Okay. Police band. We're gonna skip. You know what we're gonna do? We're gonna go back and do that IF adjustment. That's what I'm interested in today, and then we'll leave the shortwave stuff for tomorrow. Okay. What am I doing? You can't see what I'm doing. That's just as well. I'm just holding this wire here for no good reason. So the IF adjustment. I always thought the IF trap was mostly intended to keep the IF signal from leaking out the antenna. So if some of the IF or local oscillator, really the local oscillator, it doesn't make sense, does it? Local oscillator is not the same frequency as the IF. So another possibility is a strong IF signal getting out the antenna. I don't think that's very likely, because if that were happening, if the radio were somehow getting a strong IF signal back out the antenna, it would come back in the front again. I think you'd have motorboating or something going on, something weird going on. So those ideas were wrong. I believe what it's really about is, and what I've become aware of recently, and maybe shame on me, I should have known this all along, radios are sensitive at the IF frequency to IF frequency signals on the antenna. So if you in fact have some kind of noise signal right at the IF frequency here in your house or something like that, it could work its way through the radio regardless of where you tune it. It's bypassing the tuning in a sense, kind of slipping underneath the tuning, slipping past the tuning and getting straight to the IF. Now in my house, because I've become very interested in this idea, I've discovered that in fact there is a noise signal. Don't know about here. We're going to check here in a moment. There is a noise signal at 460 in my listening post. Most of the radios in there, the IF is 455. That's not far from 460. So it's possible that unless the radios have some kind of IF trap, or they have very, very good front ends. Some of my radios have tremendous front ends on them, and they can't hear it. The IF interference signal won't make it into the radio. But others, well, look, the engineer for this radio put a trap on it to stop this problem. So let's use the SDR, and we'll look and see what kind of noises are here in my shop. Anything around the IF frequency. Okay, here's the SDR shot of noises in my shop, and I'm using a. Let me just turn the sound off. I'm using just a loop of wire as a pickup coil, and it's connected to the SDR, and that's what we're hearing. Now I'm going to touch that coil, and you can see a little bit of a change in the radio. Yeah. So this is the area of interest down here, 455 area, right where I've got my pointer right now. You can see that there's just nothing. It's actually quite clear here. just a little bit above at this point is this thing. Now we can listen to this. There's nothing to hear. It's not a modulated signal. Go to the next one. It's also not modulated. If this were, if a signal like this, unmodulated signal, were sitting in the IF frequency range and we're getting into the radio, it would probably produce a heterodyne audio tone. So you'd hear a tone. As you tune the radio, the pitch of the tone probably wouldn't change. See how quietly I'm saying that? I'm not absolutely sure. Let's go to the next one. Oh, so this one's modulated. What it is exactly, I don't know. It's right at the very bottom of the AM band, 426, 526 rather. 530 is the bottom of the band. So there doesn't seem to be anything right in the IF range. Now, I have a couple other radios with unusual IF frequencies. One of them is very low at 175. That's way down here. We don't see anything too much down here. We have another one I just recently had in my shop. It had a IF of 1650, which is way up here. And here in my shop, the way I'm doing this, we don't see anything. But that same radio with a 1650 also has a second IF at 50. 50 is way down here again. And there's some general noise here. See how this kind of goes up? And you can see it on the waterfall display. And what's that sound like? Well, I don't know. Can't really hear anything. Doesn't have a buzz or a hum to it. Well, look at this interesting signal here. It just caught my eye. What is that? So I'm going to change the modulation here to if I can figure out how to do it, to I thought we'd hear something there. I think I'm jumping too far here. There we are. What would this be? Wee. So there are weird things. Now this could be very local to my shop. Now we can hear these because I have single sideband operating. Okay, just not quite tuning that one. Well, since there's nothing here, I'm not going to be able to knock any interference out. Now, let's think about this. There's something else here. There's noise here. There's noise everywhere all the time. It's not particularly high in this area. It's the same as all the way along here. But this noise will get into the radio and potentially pass through, the elements of the noise, the frequencies of the noise that are within the IF passband are going to pass through the radio, additional noise. So maybe when I adjust the IF, we can hear the noise level go down on this radio, particularly if I've got it tuned to a quiet spot, if there is such a thing. Okay, let's fool around with the radio now. So one of the things I wanted to do was take another radio like this and just tune it through the 455 range and hear what this thing picks up. This is a regular AM radio, has a loop antenna built into it. This won't tune down that low. This goes to the bottom of the broadcast band, 520. See, it says 520. Let's turn it on. So there is some noise there. Remember, there was something just around 525 or something like that. So the noise we're seeing on the SDR it matches what's being picked up here, at least in that one case. I gotta tell you, I'm disappointed. There's no noise in the IF band, but I shouldn't be. I mean, the last thing you want is noise there. So we'll go ahead now and we'll do the actual alignment process, which is simply feeding 456 at the radio and then adjusting this trimmer so the littlest amount gets through the radio. Okay, so that's what we'll set up for. Okay, radio's warming up here. So I have the signal generator attached to the antenna. That way we're not hearing anything at all. We put it on full voltage. There we are. Now the radio tuning is important in this. So right now that's probably a multiple of 456 coming through here. So we don't want to be anywhere near any of that kind of stuff. So here's a nice area, nothing happening. We'll leave it there. And we can hear the IF coming out of the speaker. So some of it is leaking through. They have not got much of a signal strength over here either. So I think the trap is not trapping. So we will now attempt to adjust the trap. Oh, whoa, whoa, whoa. Okay. Oh, this is all loose here. Ooh. Okay, not that way. Get back. Right about here. It's about as good as you're going to get. It would be interesting to remove that. Okay, so what I was hoping to do, I'll take this off, is try to identify the noise coming through the IF directly. I don't think that's going to happen. I don't think that's going to happen here. If I knock this off too far, we can just come and get it back. So I'm going to tune this. The idea is, does the noise level increase in the radio? The hiss. Okay, that's full volume there. Here we go. Didn't hear any change. No change. So we'll put it back where it was. Okay. Well, you know, you got to do these things to try to find out what's going on. Now I did that with no connection to the antenna, so maybe that's not the best way to do it. Why don't we hook up the antenna and listen to this radio now that I've done some alignment stuff. Maybe I'll make that the end for today. Okay. Now I gotta go make sure the antenna's connected to, turned on rather. See, I just left the room for a minute and I come back and it's stopping. It was making quite a racket there as I was coming back. Okay, so now we want to hook up to the outdoor antenna. Yikes. What's with the volume? With the volume right down, you can't hear that. So we know it's coming from the radio section of the radio. Okay, we'll hook this guy up to the antenna here. Watch out for the volume. That made a big difference in the hiss. Now, is some portion of this hiss coming from the IF? We'll try the experiment. I doubt it very, very much. Okay, here we go. Listening to the hiss. No. Putting it back. I was also watching the meter over here, which is barely up anyway. down. Ooh, there's a lot of volume here now. It's a nice hiss too. I like that hiss. Okay, let's make sure we're on broadcast, and we're going to run through the broadcast band. Antenna connected, ground is connected. Maybe I shouldn't have the ground on there. Let's see. Let's just see what happens here. Let's leave the ground connected. There we go. I'm already picking something up. That's fantastic. These are all community radio stations from Toronto and the area there. About roughly 100 kilometers from here. It's super sensitive. Oh, this is fantastic reception. Gotta wonder about those sounds.
Right. I mean, so the schedule is a mess right now, and it can just get messier. So I'm with you on this. Time will tell.
Whatever certification you want, becoming an architect, a doctor.
It's like the best radio in my house.
Know how to handle the stress of taking on a test. Because it might not necessarily be true that everyone... Say farewell to your commercial quality, discounted in Aspen.
Chiant. Michael, deux questions que je rêve de vous poser depuis des années. La première, c'est quand on regarde...
Let me go back. Yeah. I believe those are my thoughts.
Stay here for a second on this station. So this station's from Hamilton, and I use it often to test the sensitivity of radios. First I tune in the French station. You heard it's quite strong. It's much more local. Then I go for this Hamilton station, which is another 75 kilometers away or so. It's quite a ways away, Hamilton, from here. This radio is picking up the signal from Hamilton almost better than any radio I've found.
8:20 a.m. or our parent company, Cell Media. We're just trying to make you laugh.
I mean, that's fantastic. Now, a lot has to do with the antenna. Okay, it's not just the radio. The radio can only hear what's on the antenna. So a great radio and a lousy antenna is lousy. But a great antenna on a lousy radio, it's lousy too. Let's just see. Let's just compare. 820 here. Dial in 820. We'll compare that to this radio.
My favorite, of course,
Wow.
is the Alice for the 36 hour. Obviously, they've
Wow.
got a hold on my life now there. I get sexual prowess for 12 minutes, spend the next day and a half playing ring toss with myself.
The Hamilton station is a comedy channel. Wow, this is fantastic.
That's what caught on fire on the overnight around 4 this morning. That's six and a half hours ago, really. And it's still not clear, causing a huge delay from Brant now. Westbound QEW from Brant all the way through to approaching Nikola Tesla, so a terrible drive. 40 rebound QEW. Toronto bound, not as bad. You do have the construction both ways, it looks like. A bit of a delay through...
too big or too small. Pick up in-store or have it delivered right to your home, shop, or job site. 2. Travel is more than... You could be like, man, that would be cool. Like, that's such a...
You can't plan for an event like that, but what you can do is have the right kind of people working.
Well, okay, so this now becomes the best working radio I've ever had in my shop. Was it because of the rocking there? You see, so that rocking thing where you rock the tuning capacitor and make adjustments, I've never been very good at that. This time I took my time and I managed to get, a couple more volts on the meter over here, on this meter over here. Is that why this thing is now so hot? I don't know. Wow, fantastic though. So that's it for today. Tomorrow I will take care of the shortwave. I don't think there's very much involved in that. We'll tune up the shortwave side of this radio, and holy smokes, super performer with a good antenna. I have to keep mentioning that. It's very much all about the antenna you're using. Fantastic. Well, thanks a lot for watching. I'm sort of floored at how good this came out. It just, you never know. Thanks for watching. See ya.